Okay, so here we are with section 4.8, which is all about applications of the trig functions. And mainly in this section, you will be dealing with the sine, cosine, and tangent functions because those are the ones you can use a right triangle with. Now, because this section is dealing with a lot of things dealing with that, on your calculator, you're going to want to take and make the mode of it the degree mode so that you don't have to go in and put the degree symbol every time you're dealing with something in an angle. Or when you're trying to find an angle, you're not going to have to convert it by multiplying by 180 over pi. So if you have a Texas Instruments calculator and you want to change that, you would hit the mode button and move down until you see the radian and then go over to where it says degree and get that to be flashing and hit the enter button, and then you can push second quit. Now then, when you figure something out, when you take sine of 30, you don't have to put the degree symbol. It's just going to give you it as 0.5. On a Casio calculator, once you're into the run part of the calculator, you need to push second and the menu button, which is setup, and then scroll down, and somewhere in there it should say angle, and it's going to say rad here, and then down below at the bottom you have to choose the one that says DEG, and then the same thing will happen. Okay, so then, like I said, you're going to be dealing with a lot of things with a right triangle, and it's going to give you parts. Sometimes it may give you an angle and two sides, sometimes or angled on one side, or it's going to give you two sides, like say this is 4 and this is 7. And so if you had that, you would then set up your trig ratio, and in this case, because this is theta and we're trying to find out what theta is, and we have the opposite side and the hypotenuse, we would say sine of theta is equal to 4 over 7. So then to figure out what the angle is, you have to get this and move it to the other side, and since it's sine on this side, when you move it to the other side, it becomes inverse sine of 4/7. And so then you would take out your calculator, first take 4 and divide it by 7, and you get 0.5714. And so then you would hit second sine, and then the answer that you just got, and hit enter, and now that is telling you that the angle is 34.85 degrees approximately. So then you would say theta is approximately 34.85 degrees. And then since this is 34.85, this other angle here would be, because these two are part of a right triangle, that's 90, and a triangle is a total of 180, so you take away 90 already. These two have to be complementary, so then you would take 90 minus 34.85, and that would get you, and we'll do it with our calculator so as not to confuse, and if we subtract 90, you will get 55.15 degrees. And then you may even have to find this third side, which you can use the Pythagorean theorem and say 7 squared equals 4 squared plus x squared, where that's x. And so you'll be doing that with many, many, many problems in this section. Now, one other part of this section that you're going to deal with is bearings. And so you have to understand directions. North is this way, south is that way, and then we spell we for west and east. When you're given a direction like this, north 25 degrees east, this direction north is the first direction you move. And so we're going to be going that way, north, and then this is the second direction we move. And this one's either going to be north and south, this one's going to be east and west. Or it could be the other way around. You're not going to get a north and then a south. It's going to be north and east or west, or south and east or west. Or like I said, this could be east or west, and then that could be north or south. So for here, first direction is north, and then 25 degrees east, which is that way. So then the angle we are talking about is this one, which this then is 25 degrees. And if that is 25 degrees, then you should also know that this angle right here is going to be 65 degrees because these two form a right angle, which that means they're complementary, and 90 minus 25 is 65. Now then, it may also give you another direction. It'll say maybe it travels for 10 miles, and then at this point it may say it's going to go north and 50 degrees west. So then we have to draw another coordinate plane on here, and again we are going to go north and then 50 degrees to the west, which makes this angle here 50 degrees. And that would put this angle right here at 40 degrees. Okay? And so, and then you may have to find out what the distance is somewhere. Just remember, make some friends by making some right triangles and then figure out what you have. Another example, just in case you get one this way, it could be east 20 degrees north. So east is that direction because we're north, south, west, and east. And then north is 20 degrees, so that angle right there is 20, which would make this angle here 70. And if it went for 15 miles, and then maybe you would have to make a right triangle here, and then it may ask you how far east is it, and so then you would want to find that distance. And that is everything that you really need to deal with in section 8. So you may go back to class and try to work on some of that assignment.